All right, the next notion we're going to deal with the graphing of the trigonometric functions. And again, I'm going to just keep doing this on my talking hand version rather than the chalkboard, so I don't have to rearrange my my incredibly complicated video production studio here. We're dealing with something called a vertical shift. Now, I want you to recall something from your glory days in basic algebra. If you know the graph of f of x is equal to x squared, and so most of us should know that, I think. Well, that's the basic shape parabola. But if we said f of x is equal to x squared plus, let's say, 3, do you recall what this corresponds to? Well, if you don't, you can go back and just do a few quick little plots here. If x is 0, the function value is 0 plus 3. If x is 1, the function value is 1 plus 3. If x is negative 1, the function value is 1 plus 3. And if x is 2, or can we also see if 2 or negative 2 both go to the same value, 2 or negative 2 squared is 4 plus 3 is 7. And so the graph we generate, 0, 1, 2, 3, 1 and negative 1 both plot to 4, 2 and negative 2 both plot to 7. And so what we generate is the same basic shape, but do we see it's been shifted vertically? We've been shifted up 3 units. And so that's what this value corresponds to. If you add or subtract a value outside this primary function, that corresponds to a vertical shift. Now, when I say outside the function, I mean something like this. If we were to have x plus 3 quantity squared, this is adding or subtracting inside the function versus x squared plus 3 outside the primary function. And so if you're inside the primary function, that's this representation. If you're outside the primary function, that's this representation. If you add or subtract outside, which is what we're doing here, and that's what we're doing here, that corresponds to a vertical shift. If you add or subtract on the inside of a function, I think most of us recall that corresponds to a horizontal shift. I think we could graph a function like this, and I think it wouldn't take very long to convince ourselves, or more, maybe a better way to say it is to remind ourselves, because I think we've all studied this before, that when you add or subtract on the inside, that corresponds to a horizontal shift. And a thing to bear in mind is this: when you add outside the vertical function, you shift up. Is it clear? If this had been x squared minus 3, that would have corresponded to shifting down 3 units. So if you subtract, you shift down. If you add, you shift up. So plus means you shift up, and minus means you shift down. Beyond that, it's the same basic shape. Well, we're going to be able to work with this function in much the same fashion. You recall earlier what we did. We talked about the amplitude, we talked about the shape, and we talked about the interval over which we're going to graph this. That corresponds to the amplitude, the shape, and the change of period. But the shifting we're going to handle separately. And in fact, we're going to handle the shifting first. That actually is convenient. And so it's clear we're going to shift in this case, and I'll write up. If you want, you can just put an up arrow. Shift up 3 units. If you want, you can just write up 3 units. But we're going to shift up 3 units. Now here's what that means. Ordinarily, the axis, the nodes, would fall on the x-axis. But that needs to get shifted up 3 units. So the axis of the function, where the nodes will fall, are now going to be at 3. This is, if you will, that's the midline. This is the axis. This is where the nodes fall. Ordinarily, this would be the graph of this sine curve, and the nodes would fall on the x-axis. we're shifting that up, and now the nodes fall on the line line equal 3. There is no horizontal shift here. We'll handle that later. So the only shift is up 3 units, and then everything else is the same as before. The amplitude is the absolute value of 1, which is 1, so that means we go to 4 and down to 2. This distance is 1. So the rectangular box has top at 4, bottom at 2. The shape we know is the positive sine curve. And finally, the interval. There's no change of period, so it's clear the interval is still 2 pi because there's nothing to amend with the interval. So if this is 3, listen, there's 3, and so there's pi. There's approximately 2 pi. Pi over 2, 3 pi over 2. 1 half, 2 halves, 3 halves. And so the endpoints of the interval are from 0 to 2 pi. From 0 to 2 pi. And so the box we had before has been shifted up 3 units. And so we need to take this basic sine curve and install it in this box. And it's the same as before. The node line is no longer the x-axis. The node line is up here at positive 3. The first quarter is the peak. The second quarter is the node. The third quarter is the trough. And the fourth quarter is the node. And so that we have the graph of this function.